Good morning, guys, and I just wanted to kind of quickly go through these with you today. Um, I'm actually going to go through most of these already completed because I think for the most part you guys can actually go through a lot of this on your own because we've talked about a lot of this in the unit already. But for 3.7, I just wanted to talk about really a couple of things that either you haven't seen yet or that I wanted to explain kind of what it was or where it's found in the calculator. So in 3.7, we're looking at how many iPhones are going to be sold, kind of seeing can we use this as a predictive model. And so it gives us this data set over here with all the different original iPhones. As you can see, the three, they go from the original, the 3G, 3GS, 4, 4S, 5, and so on, all the way down to the year 2015, and the number of units sold in millions. So 0.5 means half of a million or 500,000. 1 is 1 million, 4 is 4 million, and so on. So as you can see, I have the graphs already made for you, one without the least squares regression line, so you can kind of see the dots just kind of going up like that, as well as one with the least squares regression line already put in. So as a quick kind of reminder, in your calculator, you'll need to go into the regression applet. They are kind of in the bottom middle. Once you click that, you put in all your data, you go over to graph. You guys should know by now how to put in your regression line. One key thing to remember, right, is when we use the regression line, you want to make sure that your model is the A plus BX model, not the first one, MX plus B, but A plus BX. And so from there, you can get both of those pictures. Question 2 says to describe the form. So as we can see, especially in this first one, it's a little bit easier to see. If I kind of connect these dots, it actually looks like it has kind of this curvature to it. And so it's not really in this straight line anymore. It's now following more of a curve. And so that's kind of unique compared to other data sets we've worked with so far. But for now, all we've really known how to do is, well, let me try to stick a line into it and see what happens. And so if you use your calculator, you can find the equation for the least squares regression line. Again, we should know how to do that. And then part 4 says if you go into regression again and scroll almost all the way down, there's this thing called the residual plot. And so a reminder, right, the residuals are the distances from the actual y to your predicted y. So how far was the actual y value to what we thought it would be, right? What are the distances from each of those points to our prediction line? Like how close were we? So let me get rid of those real quick. And so in the calculator, it would look something like this. So I'm going to go back over to regression. And if we scroll down, we get residual plot. And we get a graph that looks like this. And so the notes tell you to graph them on your plot. I will actually go back and you can either screenshot mine or use mine to kind of sketch it if you want, or you can use this on your own. But you'll notice the 2007 data point that's currently looks like a target up in the top left. Down at the bottom, it says x equals 2007, residual equals 1.89. So that's kind of like the y coordinate for 2007, 1.89. And then if I go over to my next one using the right arrow key, it says for the 2008, my residual is 0.79. And I can just kind of cycle through and see what all of those coordinate points actually are if you want to be a little bit more specific when you draw these out. But I did that kind of for you. And on this one, I really would recommend not just taking a screenshot of the calculator, mostly because of the axis of this one and the axis of the second one you're about to do is also going to be different. And so being able to compare them side by side is kind of important here. So I would sketch them out. If you want, I'll even just do this right now. Put them side by side so you could take a screenshot of both and just put the whole thing in if you want. It's not particularly important that you do it by hand. But um, really kind of the big important thing to note here is this red one is the one I just showed you in the calculator. And that came from finding the linear model, right? Let me put in that least squares regression line, and we could see that there's actually this pattern in this residual plot. And what I mean by that is if I look at these dots, it actually follows this kind of U-shape pattern. Now, is it perfect? No, right? You could say, oh, Mr. Bennett, you missed this little like lump right here. Okay, you're right. But for the most part, it kind of follows this generic down and then up, right? Almost like a U, kind of like a quadratic, if you think back to like Math 2, Math 3. And so maybe, since that's the case, maybe a quadratic might actually be a better fit for our data. And so that's what question 5 actually suggests. Hey, maybe a quadratic model would be best. So if we go back into our calculator, I'm going to go back, change my model. Instead of doing linear, I'm going to scroll down to quadratic. And now you can see, wow, that lines up pretty darn well with a lot of our data points, a lot closer than the line did. And now if I go into regression and go back down to the residual plot, now we get this new residual plot where I no longer have that pretty pattern. Like my points are kind of all over the place. They're kind of scattered throughout. And that's pretty much what I want to see in a residual plot. So in a residual plot, I really do want to see no pattern, right? When I see scattered out data points, that's a good thing. And so we can see that in this one because it kind of goes up and then down and then up again, down and up and down and down and up. And it's kind of just bouncing back and forth versus this top one that was very pretty, per se. Okay, so that's really the big difference here is when we can use this residual plot, looking at those differences between the actual and the y values, the residuals, to actually kind of look and see, was this model a good fit for the data that we have? And in this case, the linear model was not, but if we change that and use more of a quadratic model, it might actually be a good fit. And so from your calculator, you can actually get these two kind of new statistics here. I'll talk about them a little bit more in a second. S, or in your calculator, it's actually referred to as SR, and then R squared. And so they're in two different locations, so unfortunately it's not super easy, it's not hard to find them, but it's just a little bit tedious. But I'll show you the first one. S is pretty easy to find because it's in the stats section, which makes it easier. So S is in stats. So if you go into, you have your data, and you do this for both models. I'm just going to do this for the quadratic one since I already have that set up. But if you go back to your graph, if I just go all the way over to stats, and if I just scroll all the way down until I get to, again, in this case, SR, it says residual standard deviation. So keyword there being residual, that's the keyword you want to look out for, residual. Residual standard deviation, SR, 0.676. There it is. And we'll see that, 0.676. Okay, so that's in your stats. And again, in your calculator, that shows up as SR, residual standard deviation. R squared is called the coefficient of determination. That shows up in a different place. That shows up under your regression information. And so if I go back to your calculator, I know I'm bouncing back and forth and going pretty quickly today, but I figured you guys can kind of slow this down or watch back whatever you need to. I'm going to go back to your graph here. So here's your graph. I'm going to go back to regression, like where you would go look for your equation. And here's your model, and there's r squared, 0.983. And if I change that back to linear, there's your line, right, your straight line. Go look at that regression, r and r squared, 0.913. Okay, so it's not r, it's r squared. And we can see that we have both of those written down right here. Okay, so they're in two slightly different locations, but still pretty easy to find. You just have to know where to find them. So please make sure you watch through this, or tell your buddies if they're too lazy and don't watch through this. But what are those? And so to kind of wrap this up, again, I'm not going to go spend too much time on this because, again, you can take a screenshot of this or write this down on your own time. But the standard deviation of residuals is really kind of, it's exactly what it means, right? It's the standard deviation, how far away from average, basically, of the residual data set. And your goal here, here's kind of the key, is you really want that number to be low. We want that to be as low as possible. And so, because that means we're close to our prediction line. So the lower we are with our S or SR, the closer we are to actual prediction line, which means our prediction line is really, really accurate and is a good model. So to interpret that, right, we can use this kind of sentence frame. The actual, whatever Y context is typically about that much away from the predicted Y context using this model, the linear model, the quadratic model, the cubic model, whatever we're using. The coefficient of determination, we want that to be close to 1, because really what that represents, the r squared, is kind of like a percentage. So again, we want that to be close to 1 because we want it to be close to 100%. The closer we could be to 100%, the more accurate it becomes. And so if we look at the interpretation there, it says the r squared as a percentage of the variability. So remember, variability talks about the spread, like how far spread out our data is. So the r squared percentage of the variability of the Y context is accounted for by this model. So I'll show you those examples up above in our iPhone situation here in just a second. But that's what these two things are referring to. So again, the S and SR, the S, we want a low S, and the R squared, we want a high percentage close to 100%. Okay, so what does that look like? So for our residual, we had 0.676. So it was the number of iPhones sold is typically about 0.676 million, which is about 676,000, away from the predicted iPhone sales using this model. So again, just kind of filling in those sentence frames where we need to plug in stuff. iPhones sold being our Y context. Coefficient of determination, 0.984 is the equivalent of 98.4%. So I'll do that again, 98.4%. So 98.4% of the variability of iPhone sales is accounted for by this quadratic model. And so again, right, saying 94% of the changes of the how spread out our data is accounted for by this model is a really good thing, right? We're saying no matter how crazy kind of our data is, we've accounted for a lot of it, almost all of it, within this model, versus if we had stuck with our linear model, 91%. So would I rather only account for 91%, or do I want to account for 98%? There's a big difference there, and that's why quadratic is a much better model for our data in this scenario. And then to kind of just quickly wrap that up, again, when we're looking at our residual plot, what we want to see, a good thing to see, is that there is no pattern, right? It's just kind of bouncing back and forth. If we do see a pattern, kind of whatever that pattern is, if it's pretty nice, it's a bad thing, right? That means it wasn't a good model. Okay, I probably want to try something else in that case. So I know that was fast. Like I said, a lot of the stuff, especially early on, was stuff that you guys have learned in the chapter and are capable of doing kind of on your own. My hope was I can kind of talk about really just the brand new stuff. And if you still have questions, I will be there tomorrow, so you guys can ask away. But try to work on some of the homework questions so that if you have questions, you can ask me about them tomorrow. So please work on those. Look at your calculators, try it, try to see and make sure you can find where the SR is, make sure you can find where R squared is, make sure you know how to find the residual plots. Okay, all of that stuff is going to be on your test. And then, like I said, if you have any questions, just make sure to make a note of them, write them down, and I'll be happy to help you guys out. So I'll see you soon. Have a great rest of your day, and I'll catch you guys later.